So now that we've hopefully developed a deep understanding of what a min or a max is over an open or closed interval, what an extrema is, what a critical number is, etc., now we need to actually look at the math involved. So here are our guidelines for finding extrema on a closed interval. So again, this is specific to closed. So to find the extrema, we're going to start by finding the critical numbers, which means, of course, that I'm finding f prime, and I'm finding where f prime of c is equal to 0, and I'm finding where f prime of c does not exist. Those are our critical numbers. Then we're going to evaluate f, the original function, at each of the critical numbers over the open interval. Yes, we're talking about open interval here. Then we're going to evaluate just the endpoints. So we're going to look at the point A and the point B, whatever our endpoints are. Whatever the least of our values is a minimum, and the greatest is a maximum. So let's take a look at an example. Here we have the function f of x equals 3x to the fourth minus 4x cubed on the closed interval -1, 2. Again, closed interval. So the first thing we're going to do is that we need to find those critical numbers. To find critical numbers, we have to first differentiate the function. So that's step one, is to find f prime of x. And f prime of x, of course, we know how to find the derivative. 4 times 3 is 12. Take 4, 1 less than that makes it 3. That's 12x cubed. You get the idea. I'm not going to spend too much time on that. But what I do need to do is find out where f prime of 0 or f prime of x is equal to 0. So notice all I've done is just set it equal to 0, and then I've solved. So it's just math, people, just algebra at this point. So I'm solving to find 0 and 1 are two numbers. And again, this is not an interval, so make sure you understand the difference between the brackets. This means the set of numbers containing 0 and 1, not an interval from 0 to 1. Now, is there any place where this function is undefined? Or I guess this function is undefined? No, because if it were, say, a rational where we have an x in our denominator, then we'd have to be worried about that point. But this is a polynomial, so it's okay. It's not undefined anywhere. So I have two critical numbers, 0 and 1. Now that I know my critical numbers, I'm also going to include my left endpoint and my right endpoint. So these were the two critical numbers I came up with, and I'm also including the endpoint because we're on a closed interval. So what am I going to do now? All I'm going to do is plug it back into my original function. So remember, f of x, I'm not plugging it into the derivative because I already know that I would get 0 here and 0 here. I'm plugging it back into the original function. So essentially I'm finding that this is the point -1, 7, this is the point 0, 0, this is the point 1, -1, and this is the point 2, 16. And I'm finding from those 4 points, what's the min, what's the max? So the minimum is 1, -1, and the maximum is 2, 16, because that would be the smallest y value and the largest y value. Now keep in mind that this is where that graphing calculator can really come into play, because I can then graph it and visually see that over the interval from -1 to 2, the closed interval, that 2, 16 would in fact be the maximum value, and 1, -1 would in fact be the minimum value. So don't be afraid to grab your graphing calculator or get into Desmos.com and go ahead and look at it over that interval. You can always change the window to be, just for your closed interval of -1, 2, or you can just look at it and visually see that in that interval, that would be the min and the max. Keep in mind that we did have a couple of other critical numbers. Well, I guess we had one other critical number, which is at 0, and our y value was 0, and that wasn't a minimum or a maximum, and that's okay. It doesn't have to be a min or a max. It just is a position where a min or max could occur. Here's an example for you to try on your own, and I do encourage you to press pause and actually try this on your own. Just a reminder of the steps. You're first going to find the derivative of the function. You're going to set that derivative equal to 0 to find the critical numbers. You're also going to determine if there are any x values for which your derivative would be undefined. Those are all of your critical numbers. You will use those as test points as well as the two endpoints, -1 and 3, and compare those values to see which is least and which is greatest. When you've done all of that, press play to see how you did. So let's take a look. The first thing I would do is find the derivative of my function. So the derivative of 2x is 2. The derivative of 3x to the 2/3 is 2x to the -1/3. Then I'm going to sort of simplify this a little bit because, again, I'm really interested in not only where it is equal to 0, but also where it's undefined. And it's maybe harder to tell here, so notice the way that I've rewritten it. I've factored a 2 out of everything, and then I've rewritten x to the -1/3 as 1 over the cubed root of x. Now, I'm trying to find critical numbers. The critical numbers would be, if I set this equal to 0 and solve, notice I find a critical value of 1, or a critical number of 1. Then I have to look, because this one is not a polynomial. Our last one was polynomial, and therefore it was defined everywhere. This guy, obviously not defined everywhere, so I have to look at where that would be undefined. So what value could I not plug in for x because it would be undefined, and of course that value is at 0. So x equals 0 and x equals 1. Those are my critical numbers. And then of course I use my left endpoint and my right endpoint. I plugged all of those values back into the original equation. So remember, that's this guy up here. Original equation to find the y values. So I get -5, 0, -1, approximately -0.24. The function has a minimum of excuse me, of -5 at -1, -5. That was the left endpoint. And a maximum of 0 at the point 0, 0. And again, feel free to then graph that to verify your results.